Welcome back, everybody. Moving on to the next question. We have to find the equation of the line that passes through the point 2 and 2 and is parallel to the line tangent to f of x equals negative 3x cubed minus 2x at an x value of negative 1 and 5. So we are finding the equation of some kind of line. So we know that our final answer is going to be in this format here. And when we're finding the equation of a line, there's usually two steps. We have to find the slope, and then once we have the slope, we can take the slope, then we can plug in a point and solve for the b value. Well, notice that we're told that this line that we're going to find is going to pass through the point 2 and 2. So we already know if we can find the slope, then we can easily find the b value. We just plug in 2 and 2 for x and y, solve for b. How are we going to find the slope though? Well, notice that we're told that this line is going to be parallel to the tangent line on this function at an x value or at a point negative 1 and 5. So if we can find what the slope of the tangent is of this function at an x value of negative 1, then we know that our line is going to have the same slope as that slope because it's going to be parallel to that tangent line. So let's find the slope, the tangent slope, for this function at an x value negative 1. And we know that the tangent slope in general is what? The limit as h goes to 0 of f of a plus h minus f of a all over h. So this is the general formula for an x value of a that we've been using throughout the unit. So let's find a general expression first for the slope of the tangent, then plug in that x value of negative 1. So we would have here limit as h goes to 0 of negative 3a plus h cubed minus 2 times a plus h. So this whole square bracket here is basically this expression, f of a plus h, and then we're going to be subtracting f of a, which would be just negative 3a cubed minus 2a. And then this is going to be all over h here. Now what's going to be a pain about this, I'm actually going to continue it here as I'm going to need a lot of room, is expanding this a plus h to the power of 3. You basically have to FOIL it out 3 times. You can also use Pascal's triangle if any of you are taking data management, or if you've ever used Pascal's triangle before. Actually, you did use it in grade 11. So if you remember, you can just use the coefficient in the third row, the coefficients in the third row for Pascal's triangle. So you'd have a cubed plus 3a squared h plus 3ah squared plus h cubed. So a plus h cubed is basically this bracket here. That's what you should get. Whether you use Pascal's triangle or whether you FOIL it out manually, this is what you should get here. And then we're going to subtract or distribute that negative 2 inside the bracket. So we'll have minus 2a minus 2h. And then let's distribute the negative inside this bracket. So we'll have positive 3a cubed, positive 2a. And then this, actually let's get rid of the square bracket here. We don't need that anymore. This here is going to be all over h. And then instead of rewriting all this, I'm just going to distribute the negative 3 inside this bracket right away. So what would change here is we'd have negative 3a cubed. This positive 3 would turn into a negative 9. This positive 3 here would turn into a negative 9 as well. And then this plus h cubed would turn into minus 3h cubed. So this would be like your next line here. And then notice a bunch of things will cancel out. Negative 3a cubed plus 3a cubed, negative 2a plus 2a, and then I don't think anything else cancels out. Yeah, nothing else cancels out at this point. So let's continue this up here. So we got the limit as h goes to 0 And then let's rewrite all this. So we got negative 9a squared h minus 9a h squared minus 3h cubed minus 2h. And this is still going to be all over h. And then notice all these terms have an h, so we could factor out the h. We'll be left with this bracket up top, and notice how the h's will cancel out. And now we could plug in 0 for h. We got rid of that h in the denominator. So if we plug in 0 for h in this remaining term, this would go to 0, this would go to 0, and we're just left with negative 9a squared minus 2. So that there is the general expression for the slope of the tangent for this function at any x value or any a value. But we want the slope of the tangent at this x value of -1. So if we plug in -1 here, for a, -1 squared is 1, times -9 is -9, -9 minus 2 is -11. So that there is the slope of the tangent when x equals -1. So because the slope of the tangent at an x value -1 for the function is -11, and the line we're finding is told, or we're told that it's parallel to that tangent, then we know the slope of our line is going to be -11 as well. And then that line is passing through 2 and 2. So we can just plug in the slope and plug in the x and y values and solve for b. So plugging in a y value of 2, -11 times 2 plus b, this is -22, bring it over. 24 equals b, so our final equation is -11x plus 24. And that there is the final answer to this question.